Today we're going to look at improper integrals. Now, to prove that a function f is a probability density function, we have to show that the integral of f of x dx between minus infinity and infinity is equal to 1, where the left-hand side is known as an improper integral. These infinities is what makes it an improper integral. So how do we evaluate something like this? Well, the integral of f of x dx between minus infinity and infinity is equal to the integral between minus infinity and b of f of x dx and plus the integral between b and plus infinity f of x dx, where b is any real number. So you can just choose any number between negative infinity and positive infinity, and you can split up your integral. So now instead of one big integral like this, you're now doing two different integrals. These are both sort of proper integrals. Okay, that's good, but we need more than that. So let's take a look at this. So to integrate f of x dx between negative infinity and b, we need to find the limit. Don't worry about this part for now. Don't worry about that part. Just let's look at this part. We need to find the limit as t tends to infinity of the integral of f of x dx between t and b. Now the nice thing about this, t and b are both real numbers here, so this is a normal integral, so we know how to deal with those. But the key thing, of course, is we also need to be able to take limits. So we'd find the integral of f of x between t and b, and then we would find the limit of that expression as t tends to negative infinity. Okay. Now this side condition, this is just saying that the integral has to exist for every t up to b. The integral of f of x dx between t and b must exist. Now, to find the integral of f of x dx between b and plus infinity, well, it's just again the limit as t tends to infinity of the integral between b and t f of x dx. And again, we've got this side condition that, of course, this integral, remember this is the same as this, must actually exist for every b less than t. Alright, so let's look at an example. Suppose we're given the function f defined by f of x equals x times x of negative x squared. Now, is f a probability density function? Well, in order to do that, we have to integrate this expression and then find out if our integral is equal to 1. If it is equal to 1, then it is a probability density function. Otherwise, it's not. So, we start off with this. The integral between negative infinity and plus infinity of x times exp. This is the exponential function, by the way. Exp of negative x squared d of x. Well, we know what to do first. We split it up. So now we've got two integrals between negative infinity and 0, and between 0 and plus infinity. Okay. Now, and then we remember we're going to take limits, and we introduce the variable t, and so t, we're going to find the limit as t tends to negative infinity of this integral, and here it's when t tends to plus infinity of this integral. Notice that the number that we chose was 0, which just tends to be a nice number. But often when you're checking probability density functions, the probability density function will only be defined for certain values, and in a lot of cases that will just mean that one of these will disappear. But we'll look at an example of that further down the line. So now we've got these two expressions. Look, now that we've got these two expressions, let's concentrate then on finding the integrals. Well, we'll find the indefinite integral first of all, since that'll be easier, and then we'll just substitute in the numbers as required. So the integral of x times x of negative x squared dx. Wow, this looks like a pretty complicated expression, but it's not really, because it obeys a certain pattern. If you look at, you've got a function, in this case x, and you've got here negative 2x squared. Now when you look at negative 2x squared, you notice that this is multiplied to x. So you've got x times some x of negative x squared. Now, can we see a connection? Well, if we differentiated this, just this part in the bracket, this negative x squared, what do we get? We get negative 2x. Now, if it was negative 2x times x of minus x squared, negative x squared, then we could use, I think it's called substitution rule, to simplify the integral. But we don't have negative x squared, 2x squared, we've got x squared. But sorry, we've got x here. So we want negative 2x in order to apply the substitution rule for integration, but we've only got x. So what we'll do is we'll just give ourselves negative x 2x. So what we've done is, now I swapped the arguments around just to make things a bit clearer. And now we've got negative 2x, but we don't want to change the value of our expression. So what we do is, if we multiply by negative 2x, then we've got to multiply by by negative a half. And that will give us, so if you negative a half times negative 2x will give you x. And of course, since negative a half is just a constant, I've just taken it outside the integral. Now we can apply the substitution rule. This says if you have the integral of f after f, so this is function composition. So f after g times the differential of g, that is equal to the integral of f after g. Okay, so let's look at what this means here. Here, our function f is the exponential function. Okay, and our function g is negative x. Well, not what our function. It's the function that squares its argument and then negates it. So if you give an x, it'll give you negative x squared. Okay, and that's times by the differential of g, which is this, because if you differentiate negative x squared, you get negative 2x. So that's this expression here is the example of this. Now what our rule tells us is this is the same as just integrating f after applying g. So g, what's g? G is just negative x squared. So there we go. And the integral of f, well, f is the exponential function. When you integrate the exponential function, you just get the exponential function again. Okay, so you got x of negative x squared. So all this integral done is simplifies very nicely just to this. And of course, we still got the minus a half times x of negative x squared. Good stuff. Okay, now let's get back to our what we were doing. This is what we had. We then split it up, and then we on the limits. And now we know what this integral is. Okay, it's just going to be negative half times x of minus x squared between the limits of 0 and t here, and then here again t and 0. Okay, so that's what we got to. So now here, the next step, we're actually not almost done, even though we still seem to have a lot of maths there. We're very close, because the key thing is we substitute when we first expand this, what we've got is we substitute 0 into this, and then of course x plus 0 is just a half. It's just 0. Sorry, it's just 1. So we've got minus a half, and then this is x plus t, and then when we substitute t, we get minus a half times x of x minus t squared, and find the limit of this expression as t tends to infinity plus the limit. Of course, it's just basically swap around. So it's the limit x a half times x minus t squared minus a half minus a half. Okay, now this is t squared negative 6. This is the negative expression. So as t tends to negative infinity, this expression, so first if you square, it'll first you square it become positive, but then it's negated. So as this tends to negative infinity, this expression minus t squared tends to negative infinity too. And as its argument tends to negative infinity, x of t will tend to 0. So this just becomes 0. So we lose this. This becomes minus a half plus, and then we lose again this one, because the same thing happens. This tends to minus t squared tends to infinity, tends to negative infinity. As t tends to infinity, so x of minus t squared tends to negative infinity, and so this, that means that the limit as t tends to infinity will be, sorry, let's do that again. As t tends to infinity, minus t squared tends to negative infinity. So x of minus t squared tends to 0. Okay, so we're left with minus a half plus minus a half, which is just minus a half plus a half, which is 0. So f is not the probability density function, because of course when we integrate it between minus infinity and infinity, we do not get 1.